All right, IM1 classes. We are talking about properties of parallelograms. Moving on in our polygon unit. So we wrapped up talking about triangles and different properties of triangles. So now we're going to move on to quadrilaterals, and more specifically parallelograms. So let's talk about what a parallelogram is first and some of the properties. Starting off, a parallelogram is called a parallelogram because its opposite sides are parallel. So this side here is parallel to this one down here. And then these on the sides are parallel to each other. So that's why it's called parallelograms, actually, because the opposite sides are parallel. The important properties that we need to talk about first, we'll start off with the sticking with the sides. Opposite sides, not only are they parallel, they are congruent. Opposite sides are congruent. So mark those off. So that means they have the same length. So this one here is the same as this one down here. So if this is like 10, this is also 10. And then this side is congruent to that side. The next one, moving on to angles. Next property is opposite angles are congruent. So what I mean from opposite angles are angles across from each other. So we'll mark those off. This angle is congruent to this angle, and then this angle is congruent to this angle. All right. So they're opposite, they are the same length. There is the next one still dealing with the angles is consecutive. Consecutive angles are supplementary. Remember, that means they add up to 180. So if they're not congruent, they add to 180. So this one and this one add to 180, B and C add to 180, B and A add to 180. And the last one we're going to talk about is the diagonals. So we have, if you connect the opposite vertices to each other with segments, these segments that cut across diagonally, they are called diagonals, right? Makes sense. The diagonals bisect each other. So remember, bisect means it cuts it into two equal parts. So two congruent parts. I'm going to mark them off in blue. So this diagonal, this part, if we come in half, so B to the midpoint here is the same as the mid, or not, it's, yeah, the M to D. And then on the other side too. So AM is equal to MC. So they cut each other in half. So let's look at some examples, work through some examples of this. So indicate here opposite angles, remember, are congruent or equal. Consecutive angles are supplementary, which means they add up to 180. So here, 130, this one is opposite, it's across from it, so this is also 130. All right, this angle here is across from it, so this is also 72. Real simple on that, they're the same. Right here, these angles are next to each other, so they add to 180. So the question mark plus 132 is equal to 180. Figure out what the question mark is, you can just subtract from 180. So the question mark, that angle is, what is that? 48. They're supplementary. So the other way to do this real quick, to figure it out, you can just do 180 minus the 120 is 60. You don't need to set it up as an equation if you don't want to. But either way, this is 60. So when they're next to each other, they add to 180. If they're across from each other, they add to 360. And just for fun, just to demonstrate that, I'm gonna go ahead and do the other ones here. So we can see, actually, I'll color code it. So this is 132. So this is 48. So down here across, this would be 60. And then the one left over is 120. Across from each other are equal, next to each other add up to 180. The sides are pretty easy. So again, opposite sides are congruent or the same. So if that's 18, the side across from it is 18. If that's 24, the side across from it is 24. That's it. Wrong button. Here we go. All right, so last, the diagonals in parallelograms bisect each other. So here are the tricky ones. So it's gonna be important to label things here. So LB, so from L to B, oh wait, no. D, we're trying to find DL. So DL is 13.1. DL and LB are the same. So LB is also 13.1. 13.1. So here, let's pay attention to what you're looking for. WQ, or yeah, here we go. This part is 7. All right, and so if we go to find QU, it's getting bisected. So this is also 7, right? So if you're given half of it, you find another half, that's pretty easy because they're the same. Let's look at this here. YK, oh, here. So M, let's mark off what we have. So M to K. M all the way to K is 40.6. So these, the other parts down here, in green, so here, these are going to be the same, and they're just going to be half of 20 points or 40.6. So if you just take your 40.6 and divide it by 2, you get 20.3. So given the whole, you're trying to find the half. So these are each 20.3. So this is the same one. Finding you have Y, W, or WY. From Y to W is 29. So then you need to figure out how far J to Y and the other way. These are going to be the same, right? You just divide this in half. So 29 divided by 2 is 14.5. So these are each 14.5. Last two examples. Given QT, so Q to T, so here's 15.4. We are trying to find QS. So remember, this is cut in half. So these are equal. So this is also 15.4. So 15.4 combined with another 15.4 is 30.8. And so the last one is the same thing as that. So FS. So F to S is 8.2. And we are looking for F to D. So again, you know that this side S to D is the same as F to S. So this is also 8.2. So you do 8.2 plus 8.2, that's 16.4. So F to D is 16.4. All right, that's it for this lesson. Let me know if you have any questions, just email me, and we will see you guys next time.